Okay, so this is the number 5. It says negative x squared plus 8x minus 16 over x cubed minus 4x squared. I'm not sure if you asked for this one, but I'll do it anyway. Out of the top, let me take out a -1, or just a negative sign. So the top, if I write it equals, if I take out a negative from each of these, that would become positive x squared. That would become a negative 8x, and this would become a positive 16. In the bottom, these two terms, I could take out an x squared, because this has x cubed and this is just x squared, right, with the 4. But if you look at these two terms, I could take out an x squared. Now if I take out x squared from x cubed, I have an x left over. If I take out x squared from this 4x squared, pretty much I just have that -4. Right? So next step, so the top, you have a negative. Now in here, that part breaks down, it factors down to x minus 4, x minus 4. In the bottom, I have my x squared, x minus 4, right? Just this bottom piece just gets pasted there. This entire piece can knock off either this one or this one, your choice, right? So we can knock these ones off. So all that's left on the top is a negative, and then you have x minus 4. And on the bottom, all we have left is an x squared. So after factoring and simplifying, this is what we get. Now number 6, it says 49x minus x to the third over 7 minus 6x minus x squared. Now out of the top, if I write equals to set up my next step, out of the top I can take out an x. So this would be 49 minus, if you take away an x from x cubed, you have x squared. Now on the bottom you could factor it. You could, it looks kind of backwards, because usually you have something where the x squared is first, and then an x, and then the number. So this whole thing looks like it's sort of backwards, but it still factors down to something like this. It factors down to, we have a 7 there, we need a 1 here, this is going to be minus x there, and this is going to be positive x here. Now the reason I put the positive here and the negative there is because right there, those guys multiply to negative 7x. Right? That's negative 7x. This multiplies to give you 1x. So when you have negative 7x and positive 1x, you'll have negative 6x right there. Okay? Now, let me see. So back at the top, I have an x. Now, this bit here, that's one of those difference of perfect squares. This piece factors down to, the square root of that is 7. So I have a 7 and a 7. The square root of x squared is x. One's a plus, one's a minus. Okay? Now the bottom stays the same. I have 7 plus x. And then I have 1 minus x. This is kind of messy. It's just, this board is tiny, you know, so forgive me. I gotta get a bigger board. So these ones here, these are gone. So we have an x, and then we have 7 minus x, and on the bottom I have 1 minus x. Okay? So this was a little harder than the previous one, but that's what you end up getting. I mean, I could have been clearer here. It's just, you know, there's so much going on here, right? I mean, especially factoring something like this guy. This was tougher. Seeing how this becomes this here, that's a problem in its own, you know, but we end up getting this here. Now, as for the test, I'm not sure what order I'm doing these in, but I'll just do the ones that I see that are a little bit off. There's one that says subtract, and it says 2x to the third plus 4x squared minus 9x. Notice it says this, and then you see the word from, and then the next part is negative 5x, what is that, negative 5x cubed, and then it says plus 4x minus 12. Now, notice the word from. So we have to take away this from this, right? So what we have to do, since we're taking this away from this, it's like this part goes first. And from this, we're going to take away this guy, right? So when we set up the subtraction, because the problem says subtract, we actually need this to be on top. And on the bottom, we need this one. And I line it up, right? Make sure that these are lined up, like x cubed. Oh, look, yeah. Actually, as a matter of fact, I have to rewrite this top part. Because if you look here, that says negative 5x cubed. So it says x cubed. But now I need something that says x squared. There's no x squared term here, right? So you have to insert a plus 0x squared. Okay? And then you continue, plus 4x minus 12. So then we have x3, x2, x1, and then just the constant. Okay? And then we said we're going to write this on the bottom. So that's 2x to the third. That's positive 4x squared. That's negative 9x. And there's nothing underneath the negative 12 because this doesn't have any number at the end. So you can just put a plus 0. Now notice the problem says subtract. So what I'm going to do is I need all this top part, and then I need minus all of this. Okay? So we're going to see how this negative reaches out to this, this, and this. So let me draw my line now. Okay, so we have negative 5 minus 2. So negative 5 minus 2, that's negative 7. X to the third. You just attach the x3. Now let's do the next one. 0 minus 4. So 0 minus 4, that's negative 4. Right? And then check this one out. So this is 4 minus negative, right? So minus negative becomes positive. So really this is 4 plus 9. Right? So 4 plus 9 is just 13. You need to attach the x. And then negative 12, take away nothing, right? Just a 0, so it's just negative 12. So after we subtract, right, we end up getting this. Now, I mean, I'm sure you know how to do this one. It's just the key part was it's this from this, right? So we need this first, and then we take away from this, that. And so this is what we end up getting, this guy here. So there's one that says divide, where you have a squared plus 5a plus 10 divided by 3a plus 2, I believe. Yeah, that's right. Now, you set it up as long division, which is exactly what you're supposed to do. So you have a squared plus 5a plus 10, and outside you have 3a plus 2. So now that I have it set up, let me take this away, just to have room. So the way you do the division is as follows. Now, that says 3a. So 3a times what gives you a squared? Well, focus just on the a. A times what is going to make a squared? Well, a times a, right, is going to give you a squared. So I'm going to have an a. Now notice I put it above, not here, but here. I put it above the second guy because here I have two parts. So whatever number I'm going to put up here, I put it above the second part, right? So now 3a times a is 3a squared. But I don't want 3a squared. I want a squared. So what I have to do is I have to put a 1/3 right there. Okay? Because what happens when you go 3a times 1/3 of a? Well, the 3 and the third go away because they're reciprocals. Right? So those go away. And then a times a gives me a squared. So I know that this is exactly what I want. So now what I do is I take this thing up here and I multiply it to both of these guys. Right? So let me see. So I'm going to go 1/3 a times 3a. We agreed that's a squared, and I write it right there. So I went this one times this one, and I wrote it there. So now I'm going to go this one times this one, whatever I get, I'll put right here. So 1/3 of a times 2, if you do the multiplication, 1/3 times 2 is 2/3, so I'm going to write plus 2/3, and then a. Right? So now what I do now here is I have to subtract. Okay? It's going to be these two minus these two. So let me put my negative right there. So this is sort of like the one we did before where there was a subtraction involved. A squared minus a squared goes away. It's just nothing, so I won't even write anything. 5 minus 2/3. If you do the common denominators and fractions and stuff, 5 minus 2/3 should give you 13 over 3a. Okay, you have to get common denominators because that's like 5 over 1. It's like 5 minus 2/3, right? 5 minus 2/3. Well, there's a 1 down there, so I have to multiply this by 3 top and bottom. That's 15 minus 2, which is 13 over. So this is what you end up getting. And let me see, what were we doing? Yeah, so we did these two minus these two. So these are gone, and you subtract these guys, and you end up getting this. Now this one falls, plus 10. Okay. Now this next part's kind of tricky. I need something here, such that 3a times this thing that I'm about to write gives me this here, right? So 3a times what gives me this? Notice that the a already matches with the a. So really I just have to take the number 3 and multiply it by something to give me 13/3. Okay? Now it's going to end up being plus. It's going to be 13 over 9. The way I know it's that is because when I go 3 times 13 over 9, what happens is this 3 reduces with this 9. And this 9 becomes a 3 in the bottom. See, because 3 times 13 over 9, when I multiply these guys, notice there's a 1 under this guy. And this reduces away with this one, and that becomes a 3. And I get 13/3, which is what I want here. Okay, so that's a delicate part, and it's not easy to see, but I'm going to need 13/9. Now 13/9 times this gives me 13/3 a, and now I have to go 13/9 times this 2, right? And that gives me, what, 13 times 2 is 26, and it's just 9 on the bottom. You don't go 2 times both of these guys. You go 2 times the 13, that's 26 over 9. Okay? Now again, I subtract. This minus itself goes away. 10 minus 26/9. Yeah, you got to get common denominators. So 10 minus 26 over 9. Underneath the 10 there's a 1. You need common denominators, so this is a 9. This is a 1, so I have to multiply this by 9, times this by 9. That ends up being 90 minus 26. 90 minus 26, 64. So you get 64 over the common denominator, which was 9. We're pretty much done. So what we end, after all this division, we get this part, and this is a remainder. The way you write it is like this. So I have, I'll write it up here. So I have 1/3 a plus 13 over 9, and then plus, now my remainder was this, 64 over 9, but I have to put that above this, whatever this is. In this case that says 3a plus 2. Okay, so I end up getting all this. Right, I just ran out of room, but this was a nasty problem, okay? And if it was hard to follow, it's understood, because this is not an easy problem, but that's what you end up getting over there. Okay, there's one that says that you have to find an equation of a line through the point -1, 4 that is perpendicular. We've seen this before. That's perpendicular to some random line. This is 2x plus 7y equals 35. Okay, so this line, it's not our line, but we need this line because the equation that we come up with, the line that we have to come up with, is perpendicular to this. Okay? So we remember y equals mx plus b. So what I'm going to do first is I'm going to rewrite this equation into y equals mx plus b form. So to do that, I have to move first the x's to the other side. So let me subtract 2x. These are gone. So I have 7y equals, that's -2x followed by a positive 35. Now I need y alone. So I have to divide 7 into every term. These are gone. Y equals, that says -2 over 7x plus 35 divided by 7 is exactly 5. Now again, this is not our equation, but we know that our equation is perpendicular to this one. So this is y equals mx plus b. The slope m of this random equation is negative 2 over 7. Now if we remember what we did before, if we're perpendicular to a slope of negative 2 over 7, that means our slope is going to be, you have to turn it upside down, right? You got to turn this fraction upside down and switch the sign. So if you switch the sign, it's going to be positive. If you turn it upside down, it's going to be 7 over 2. So our slope, m, is going to be 7 over 2. And we have a point because our line passes through this point, and it passes through this point and it has this kind of slope. So remember point slope form that looked like this? This was point slope form, where we have m, the slope, and we have a point, x1, y1. Now my slope is 7 over 2, so 7 over 2 is going to go right there. Now this is x1 and this is y1. So I'm going to take x1, this negative 1, and put it right there. And I'm going to take 4, which is y1, and put it right there. So this stays y minus, now y1 we said was 4, equals m, which we said was 7 over 2, parentheses, x minus, and now what's x1? It happens to be negative 1. So this negative negative really is just a positive. Now I think your teacher said that he or she wanted only slope-intercept form. So what we have to do now is distribute the 7 over 2 to this and to this. Okay? So 7 over 2 times x is 7 over 2x plus 7 over 2 times 1 is just 7 over 2. And this just stays the same. So to get this y alone, I go plus 4. And I go plus 4 to this one because these are just the regular numbers, right? This has an x. These are gone. Let me write it here. So y equals, this is still 7 over 2x. And 7 over 2 plus 4, again, if you get common denominators and all that, you should get positive 15 over 2. So this is our equation. Because this equation contains this point, and it has this kind of slope, which is perpendicular to that other equation that we started with. So this is the answer that we need. There's another one that says evaluate f of negative 3 if f of x is equal, that says 2x squared minus 6x minus 4 over 2x plus 10. I believe that's what that says. Yes, so I saw your work. I mean, you're supposed to take this number, negative 3, and plug it in for all of these x's. Okay, so let's see. So this would be something like, so f of negative 3 equals 2, and then negative 3 squared minus 6, and then you have negative 3. No, it's minus 4, all that over 2, and then that's negative 3 plus 10. Let's see, next step. Here, negative 3 squared is negative 3 times itself, right? So negative 3 times negative 3 is positive 9. So this is 2, right? Because a negative times a negative is positive. So that's 9. Let's see, that's negative 6. Negative 6 times negative 3 is positive 18. That's just a negative 4. On the bottom, we have, what is that, negative 6 plus 10. Next step. 2 times 9 is 18. 18 plus 18 is 36. 36 minus 4 is 32. On the bottom we have 6 negatives going up against 10 positives. You subtract, right? 10 minus 6, that's 4. And 32 divided by 4 is exactly 8. So we get 8 out of that.